In today's lesson, we'll be learning about surface area of composite figures. In a previous lesson, we learned that finding surface area involves finding the area of each face and adding them up. Since these faces are all squares or rectangles, you can use the formula length times width. In our first example, we want to find the surface area of this composite figure. To do that, we need to find the area of each face, then add them up. I'm going to start with the face on the front. This face is a rectangle. We know the length of one side, but we don't know the length of the other side. But since this is 5 millimeters, that would mean this would be 5 millimeters as well. The formula for area of a rectangle is length times width. The length is 15 and the width is 5. 15 times 5 is 75. However, this rectangular face is duplicated on the other side of this composite figure. Therefore, we can take this 75 and multiply it by 2, which would give us 150 millimeters squared. I want to focus on this face next. This face is a rectangle, and the equation for area of a rectangle is length times width. The length happens to be 9, and the width is 5. 9 times 5 is 45. However, this face is duplicated on the other side of this composite figure, which means we can take this 45 and multiply it by 2, and that is going to give us 90 millimeters squared. I want to focus on this face next. This face is a rectangle. I have the length of one side, but I don't have the length of the other side. Well, if this is 9 millimeters, that would mean this also has to be 9 millimeters. We know the equation for area of a rectangle is length times width. The length here is 9, while the width here is 4.5. 9 times 4.5 is 40.5. However, this face is duplicated on the other side of the composite figure. Therefore, we can take this 40.5 and multiply it by 2, and that would give us 81 millimeters squared. I'm going to focus on this face next. This face appears to be a square or a rectangle. We don't have any dimensions for it. However, if this is 6 millimeters, that would mean this would have to be 6 millimeters as well. Furthermore, if this is 6 millimeters, this side would also have to be 6 millimeters. The area of a square is length times width. The length is 6 and the width is 6. 6 times 6 is 36. However, this face is duplicated on the other side of this composite figure. Therefore, I'm going to take my 36 and I'm going to multiply it by 2, which is going to give me 72 millimeters squared. I'm going to focus on this face next. This face appears to be a rectangle. We have one of the dimensions, but we don't have the other. Well, if this is 9 millimeters, that would mean this would have to be 9 millimeters as well. The formula for a rectangle is length times width. The length of this rectangle is 9 and the width is 6. 9 times 6 is 54. However, this face is duplicated right over here, and it is also duplicated on the other side of this composite figure. Therefore, I'm going to take this 54 and I'm going to multiply it by 3, and that's going to give us 162 millimeters squared. Last but not least, I'm going to focus on the bottom of this composite figure. This face is very difficult to see. It appears to be a rectangle, and the equation for area of a rectangle is length times width. The length here would be 15, and the width would be 9. 15 times 9 is 135. There is only one of these faces, therefore it is 135 millimeters squared. Now that I have the area of each face, I can add them up. I've gone ahead and done that already for you. Therefore, the total surface area is 690 millimeters squared. When calculating surface area, it is important to note that you do not count any overlapping faces.